In this video, we will take a look at Leetcode problem 226, which is about inverting a binary tree. Now, a binary tree is an abstract data structure where each node at most has two children. To invert a binary tree, we can see that a node, for example 4, has two children, 2 and 7. We just need to swap them. So for each parent, we need to swap the left and right node. Let us see how we can do this. The method I'm going to use here is breadth first search, or BFS. It is a graph traversal that we can use on a tree data structure. It consists of a queue, which is also an abstract data structure that follows the first in first out principle that will store for us the nodes of the tree. We start with the root and we add it to the queue. Next, we add all the children of 4, which they are 3 and 5, and we repeat the process. The children of 3 is 1 and 2, then the children of 5 is 6 and 7. Now 1, 2, 6 and 7 are leaf nodes, so they don't have children. So we can stop here and the queue represents the traversal order of our tree. Now how are we going to use this technique to solve this Leetcode problem? Say we have the same tree and we have a queue which we will use to solve this problem. We can start first by adding the root to the queue. And here we can start a loop. We can say that as long as the queue is not empty, we will perform the following procedures. What I want to do is take the front element of the queue and swap its left and right nodes, or its left and right children. So 4 has elements 3 and 5 as its children, right? So what we can do here is simply swap them, and that's it. Next, what we can do here is we can pop the front element from the queue, and we're going to add the children of 4 to the queue. Now, before we do that, we need to check if its children are null, because if one of the children or both of those children are null, then there is no point of adding null to the queue. In my case, I will add 3 and 5 to the queue, and like this, I could repeat the process. Now I will go to the front of the queue and get the front element, which is 3, and check what are the children of 3. They are 6 and 7, so let's go ahead and swap them. Now we can go ahead and pop 3 and add 6 and 7 to the queue. Now we go and do it again. The front element of the queue is 5, so we get 5 and we swap its children, which is 1 and 2. Then we can remove 5 from the queue and we can add 1 and 2 to the queue. Now we can clearly see that 6, 7 and 1 and 2 are leaf nodes, so they don't have children. So I could go ahead and just pop them out, and at the end I retrieve or I get a queue that is empty. I can exit the loop and return my new inverted binary tree. Now I hope you get this idea, because right now we're going to translate this idea to code. So before we start, I just want to tell you that in C++ we can use a built-in queue data structure or data type, which it's provided by C++ by simply saying include queue. Okay, and again, a queue is a abstract data structure that follows the principle first in first out. So right now inside this class solution, and more specifically inside the invert tree function, let's go ahead and implement our idea into code. Okay, so first what I'm going to do, I'm going to check if the root that I have is equal to null ptr. What I just want to do is simply return null ptr. Okay, that's it. Now in case root is not null ptr, then we can go ahead and do our process or procedure. What I want to do first is I want to declare a queue. So because I included a queue right here, I could go ahead and use this data type or data structure, and I want to declare a queue that will store 3 node pointers like this. Okay, inside this queue, or let me just first of all name my queue. So I'm just going to say, for example, Q, like this, the letter Q. Okay, this represents our queue. Okay, now at first what we want to do is we want to add to the queue our root. So what I'm going to say is queue.push, and I'm going to add my root to the queue as in the beginning. Now I'm going to go ahead and write my while loop. So I'm going to say while like this, and what will be the condition? So I want to say as long as queue.empty. So this I'm saying as long as the queue is empty. What I want is I want to say as long as the queue is not empty. So I could just say use the negation operator, which is the exclamation point. So as long as my queue is not empty, I want to go ahead and execute the following block of code. What I want to do is I'm going to declare a 3 node variable that will store for me the front element of the queue. So I could go ahead and use it later on. You'll see what I mean. So I'm going to say node like this, and I'm going to say queue.front. This will get for me the front element inside my queue. Now I could simply go ahead and say queue.pop. Like this, I could pop the first element or the front element of the queue, and because I have the front element of the queue stored in this variable, now I can go ahead and work with it. So that's why I just pop it right now to be able to work with the front element that I stored inside this variable. Now what I'm going to do, I'm going to go ahead and say the following. I'm going to use a built-in function called swap. And swap is a built-in function in C++ that takes two arguments. You can give it two arguments. And for example, if I had like int a equal to 0, int b equal to 1, if I say swap a, b like this, I will obtain at the end a equal to 1 like this and b equal to 0. So it will simply swap variables together. This is what the function swap does. Now I'm going to use it here in my case to swap the left and right child of my node or of my front element of the queue. So what I'm going to do here is I'm going to say node left, I want to swap it with node right. So I'm swapping my left child and my right child together. Alright, this is what I'm going to do right now using the swap function. After this, what I want to do is I want to make sure or check if my node left is different than null PTR. So if the left child is different than null PTR, what I want to do is I want to go ahead and add it to the queue, like this. However, if it is null PTR, I don't want to add it to the queue. So that's why I made sure that I put this if statement right here. And I'm going to do the same thing for the right child. So I'm going to say node right like this. If it is different than null PTR, that means it's good to go. I could go ahead and add it to my queue like this. Node right. Like this. And so this is it. And the loop will continue on. And until the queue becomes empty. Once the queue is empty, what I'm going to do down here, I need to return a Treenode. So what I'm going to do, I'm going to say return root like this, and now my tree is actually inverted because of what we did right here. So I hope you enjoyed. So this is it for this Leetcode problem. What we did is we used BFS approach or breadth first search approach to be able to solve this Leetcode problem. So I hope you enjoyed, and make sure to subscribe to stay up to date for the next video.